Hi everyone. So in this video we're going to actually be integrating exponential functions. Now the main thing that you have to know is anytime you find the integral of e to the u, the same exact way as if you find a derivative, it's just e to the u. Now the only thing is this exponent, this u right here, has to just be one single term. An example would be e to the x. Anything other than e to the x, for example e to the x squared or e to 2x, anything other than just x, you have to apply U-substitution. Alright? So once you know that, we're just going to go ahead and do a couple of examples. Now we integrate this and we go, oh well, this exponent is not just an x anymore, it has a 3. So because of that, you have to do U-substitution, and your u is always going to be the highest exponent. In this case it's just 3x. So we know this is going to be this 3x. When we integrate this, we're going to make u equal to the exponent, du over dx, then solve for x so that you can get dx alone. Remember, the shortcut instead of cross multiplying is just switching these two. And then once you're here, you're going to plug everything in. This becomes e to the u, du over 3, and then once you have that, just pull this 3 on the outside. So it's 1/3 antiderivative e to the u in respect to u, and the antiderivative e to the u is just e to the u, so your final answer is 1/3 e to the u plus c. But remember, you don't want e to the u because you actually want what u equals to. So 1/3 e to 3x plus c, and that equals to y. Okay? Now there is a shortcut, and this works only if that happens to be one single term to the x, and not like to the second power, to the third power, x to the first power. And a couple examples of those are, let's just say, I'm doing over here, let's say I had e to the 4x and want to integrate this in respect to x. This answer is going to become 1/4 e to the 4x plus c. Now how do I know this? Well, look at the one you just did, e to the 3x. What happened to this 3? Where did it go? It went to your denominator. 1/3 e to 3x plus c. Let's try another one. E to the 5x. Well, because I noticed it's 5x, this is going to drop down to become 1 to the 5th, 1/5 e to the 5x plus c. And that's the shortcut, okay? But unfortunately, not everything's going to be that easy. Sometimes you're going to have to do a couple of more steps. In this example, you'll notice you have one equation times another equation, in this case it's e. So you know you have to use substitution, but the problem is, how do I know what u is going to be? Well, I need my exponent to be e to the u. I need it to be u. So because of that, I automatically know that u is always going to be my exponent. Find derivative in respect to u. Solve for it. Substitute everything in. Now you'll notice I did everything right, because what happens to these two x to the 4ths? They cancel. Well, what am I going to do with the 6 and the 5? You just pull it out. So it becomes 6/5 integral of e to the u du, and the antiderivative of e to the u is just e to the u. But once again, you don't want your exponent to be u, you want your exponent to be what u equals to. So this final antiderivative is 6/5 e to the x to the 5th plus 4 plus a c, and that's what y equals to. That's your general solution. Okay? Now this is a constant pattern. Anytime you notice that there's only one e and you have to find antiderivative as another function, your u is always going to be your exponent. Every single time it's always going to be your exponent. Okay? Do a couple more examples. Now this problem's a little bit different. Hopefully the first thing you notice is the fraction. Now because it's a fraction and we know we have to do U-substitution, it's either going to be either U-substitution or we're going to split up. So the second you see a fraction, I always want you to remember that you're either going to split them up or use substitution. Because there's only one term in your denominator, that means you have to split it up. An example would be like this. Now the reason why I split it up is because anytime you have the same bases, what can you do with the exponents? You subtract them. So your next step is just subtract them. 4x minus x will give me 3x. 2x minus x will give me just x. and then this just leaves me with e to the x. But the thing is, I don't really want to work with e to the x on the bottom. Same exact way you couldn't find antiderivative when x was on the bottom, you can't find an antiderivative when e is on the bottom. So I'm going to go ahead and bring it up. Remember, when you bring it up, the exponent becomes negative. So this becomes 4e to negative x dx. Now when you have a problem like this, remember the shortcut that I taught you? What happens to that exponent? When you find your antiderivative e to the 3x, this exponent just comes in the denominator. 1 over 3 e to the 3x. But what about this exponent? It's just 1, so it's 3 over 1, so this becomes minus 3 e to the x. But what about this exponent? Well, because it's negative, it's going to be 1 over negative 1, which would be negative 4 e to the negative x plus c, but you don't want the negative exponent, so you're just going to rewrite this. And this is your general solution. This is what y equals to. So anytime you notice your equation has a fraction and there's one e in your denominator, split them up to every single term. Combine the exponents by subtracting them because they have the same base, and then apply the shortcut to find your antiderivative. This exponent just becomes a fraction, e to the x is e to the x, and then don't let the negative confuse you. This negative will technically just be 4 over negative 1 because that's the shortcut, which will give you negative 4. And then don't forget the plus c, and then rework it, negative exponent drops down. Okay, and for our last example, you'll notice same fraction, but what about the bottom? 2 terms. So because it's 2 terms on your bottom, you have to do U-substitution. Find your derivative. Get dx alone. Now how do I know I did this right? Look what dx equals to, and look at my top. You see how they cancel out? So now I'm just left with 1 over u du, and what is antiderivative of 1 over u? Ln absolute value of u plus c, but once again, I don't want to leave it as u, I want to put what u equals to. So y is equal to ln absolute value e to x minus e to the negative x plus c, and that's my general solution. So whenever you have more than one term on your bottom, you're always going to use substitution, and your u is going to pretty much 98% of the time is going to equal to the bottom. And you just treat it like normal, okay? So anytime you have, just reviewing, anytime you have one e in your equation, set your u equal to your exponent every single time. Anytime you have a fraction where e is in your denominator, just one e, split them all up and combine the exponents by subtracting. And anytime you have a fraction and you have more than one e in the denominator, make u equal to your denominator, and it's going to work every single time. Alright, good luck guys. Hope it helped.